Example. Evaluate double integral on d roots 4 a square minus x square minus y square dA over the region in the first quadrant bounded by the circle x square plus y square equal to 2ay. A is a constant. Now, firstly, we draw the region. Questions says us first quadrant. This is first quadrant. This area. Circle is x square plus y square is equal to 2ay. This circle is this a 2a, this area d. If you can see directly the circle, you can do this calculation. X square plus y square minus 2ay plus a square minus a square. These are same equations. So x square plus y minus a square, because this is y minus a square and is equal to a square. So center of the circle, x coordinate is 0, y coordinate is a. Center of the circle. And radius of the circle is a. So this is 2a and origin, x and y. If we use polar coordinates, the circle has equations. You know, this is polar coordinate. X is equal to rho cos phi, y is rho sin phi. So x square is rho square cos square phi plus rho square sin square phi is equal to 2a rho sin phi. And this rho square cos square phi plus sin square phi, this is 1, and then goes rho is equal to 2a sin phi. Does the semicircular region D? This is rho and phi. Phi is 0 from 0 to p divided 2, 90 degree. And rho is from to 0 and goes to these equations. So if we use the polar coordinates, new region is rho and phi. So from 0 to p divided 2, and from 0 to 2a sin phi. Equations say us. We have double integral on d roots 4a square minus x square minus y square dA is equal to double integral on new d roots 4a square minus rho square, because we write x is rho cos phi, y is rho sin phi. Rho square cos square, rho square sin square, cos square plus sin square is equal to 1, so rho square. And we remember the Jacobian. Jacobian of the polar coordinates is rho. This is Jacobian. And nu dA. And is equal to, this is constant, these are constant boundaries. So from 0 to p divided 2, and from 0 to 2a sin phi, and roots 4a square minus rho square rho d phi. Now let u is 4a square minus rho square. Du is minus 2 rho d rho. This is constant. And rho d rho is 1 minus 1 divided 2 du. This is minus 1 divided 2 du. And one divided 2 is a constant, goes to heat. minus 1 divided 2, 0 to p divided 2, and v, and rho is 0. If you write rho is 0, u is 4a square. And we write rho is 2a sin phi, u is 4a square minus 4a sin square phi, and u for a square 1 minus sin square phi, and then this is cos square phi. U is 4a square cos square phi. U is 4a square cos square phi. U 1 divided 2 du d phi, because this is u. Now we calculate easily. Minus 1 divided 2 from 0 to p divided 2, 2 divided 3, u powered 3 divided 2, from 4a square to 4a square cos square phi d phi. And this, so 1 divided 3 from 0 to p divided 2, 8a cubed minus 8a cubed cos cubed theta, sorry, phi d phi, and then is equal to 4p a cubed divided 3 minus 8a cubed 3 from 0 to p divided 2 cos cubed phi d phi. Cos cubed phi is 1 minus sin square phi product cos phi, because this is cos square phi. If we say sin phi is equal to v, cos phi d phi is dv. So 4p a cubed divided cube 3 minus 8a cubed divided 3 phi is 0. So v is 0. And phi is p divided 2, v is 1. And 1 minus v square, because we say sin phi v, and dv is equal to calculate easily. 4pa cubed divided 3 minus 16 divided 9a cubed. This is solution. Now, another example. Evaluate double integral on d 3x plus 4y square dA, where D is the region in the upper half plane bounded by the circles x square plus y square is equal to 1 and x square plus y square is equal to 4. Firstly, we draw the area. Upper half plane region. Upper half plane. So this is upper x, y. And this is x square plus y square is equal to 1, and this is x square plus y square is equal to 4. So radius is 2. Minus 2 minus 1 area, this area. D. The region D can be described as D is xy, so y is equal to, y is equal bigger than 0 and 1 is equal smaller than x square plus y square is equal 0 then is equal smaller than 4. This area. This is Cartesian coordinates. In polar coordinates, we think the polar coordinates, these coordinates, rho and phi. Phi is from 0 to p. From 0 to p. And rho is from 1 to 2. In polar coordinates, from 1 to 2. And phi is from 0 to p. Therefore, polar coordinate is x is rho cos phi, y is rho sin phi. So, by formula in polar coordinates, from 0 to p, rho is from 1 to 2, and we write For x, rho cos phi, and for y is rho sin phi, and 3 rho cos phi plus 4 rho square sin square phi. And we remember the Jacobian. Jacobian of polar coordinate is rho, and d rho d phi. And this is 3 rho square cos phi plus 4 rho third sin square phi d rho d phi. And is equal to, firstly, integrated for rho, and rho third cos phi plus rho fourth sin square phi. Rho is 1, 2, 2 d phi, and calculate easily. 7 cos phi plus 15 sin square phi d phi, and sin square phi is 1 minus cos 2 phi divided 2, and is equal to 7 sin phi from 0 to p, and 15 from 0 to p, 1 minus cos 2 phi divided 2 d phi is equal to 0 plus 15 divided 2 phi minus 1 divided 2 sin 2 phi from 0 to p is equal to 15p divided 2. This is solution. And now another example. Evaluate double integral on d dA over the region that lies inside rho 3 plus 2 sin phi and outside rho is 2. Firstly, we draw the area. This area a bit hard. Rho is to this circle, and this is rho is 3 plus 2 sin phi. Area is this area. This is D. We need to know that value of phi for which the two curves intersect. This is important point. We can determine these points by setting the two equations and solving. First equations is these equations, and other equations is this rho rho. So 3 plus 2 sin phi is equal to 2. So sin phi is equal to minus 1 divided 2. So phi is 7p divided 6 and 11p divided 6, or minus p divided 6. This is and this b and alpha. Beta is 7p divided 6, alpha is minus p divided 6. The region in polar coordinates described as minus p divided 6 is smaller than phi is smaller than 7p divided 6, because this is p area, and rho is this is lower boundary and this is upper boundary. So 2 is equal smaller than rho is equal smaller than 3 plus 2 sin phi. The function that is the closest to the origin is the lower bound for rho, and the function that is the farthest from the origin is the upper bounded. The range of phi increases from the lower limits to upper limit as we enclose the region. So d double integral on d dA is equal to nu d area and from minus p divided 6 to 7p divided 6, and rho is 2 to rho is 3 plus 2 sin phi. And you remember the Jacobian. Jacobian of the polar coordinates is rho and d rho d phi, and is equal to minus p divided 6, 7p divided 6, 1 divided 2 rho square, 2, 3 plus 2 sin phi d phi is equal to minus p divided 6, 7p divided 6, 1 divided 2, and 9 plus 4 sin square phi plus 12 sin phi and minus 4 d phi. And you calculate this integration easily. Do you remember sin square phi is 1 minus cos 2 phi divided 2, and then calculate easily. This is solution is 14 p divided 3 and plus 11 roots 3 divided